What if everything you thought you knew about space, time, and matter was just a simplified projection, something less fundamental?
Right, like a shadow on the wall.
Exactly. And what if the universe isn't built on some static stage, but more like a dynamic, swirling field of something called coherence?
A fundamentally different starting point.
Welcome to the deep dive. This is where we take some really dense, fascinating material and we try to distill it down into the most important nuggets for you.
Get to the core ideas.
Today, we're plunging into some seriously groundbreaking, maybe even mind-bending work by Philip Lilien. Specifically, his paper Finsler Coherence Phase Space. It's part of a much larger work, his Unified Coherence Theory of Everything, Volume 4.
Yeah, it's ambitious stuff. Really ambitious.
And Lilien isn't just suggesting minor tweaks here. He's proposing, believe it or not, an ontological replacement for spacetime itself.
He's not modifying spacetime. He's saying spacetime as we know it is emergent from this deeper structure.
So our mission today is to really unpack this radical redefinition. Can you imagine a universe where things like mass, time, spin, even the dimensions we perceive, they aren't the basic building blocks?
Right, not fundamental inputs.
Instead, they emerge from something Lilien calls a directional coherence field. We're going to dive deep into the mathematical backbone of this theory.
And show how familiar concepts, things we take for granted in physics, actually get derived from this completely new, more fundamental geometry.
This is where it gets, well, frankly, really interesting.
Yeah.
Let's set the stage first, though. Why do we even need such a radical departure?
Well, modern physics, despite its incredible successes, is sort of fragmented, isn't it?
Yeah, it's like a tale of two cities. You've got Einstein's general relativity, brilliant for gravity, large scales, cosmology.
Describes the universe beautifully on the macro level.
And then you have quantum field theory, unbelievably successful for particles, forces, the small scale stuff.
Absolutely dominant in its realm.
But try to get them to talk to each other, especially at the foundations, geometrically speaking. They just don't mesh. They speak different languages.
Exactly. And that's not just, an aesthetic problem. It leaves some really fundamental questions unanswered. Big ones.
Like the origin of mass. The standard model has the Higgs mechanism, right?
Right, but the Higgs field, it sort of gives mass to particles. It doesn't really explain why mass exists fundamentally or why particles have these specific masses they do, these sort of arbitrary values.
Or why they come in 3 generations, like the electron, muon, tau, identical except for mass. The Higgs doesn't derive that structure.
No, it accommodates it. The values are put in by hand, essentially. It feels, well, incomplete, like a patch rather than a deep explanation.
And what about other intrinsic properties, like spin or chirality, the handedness of particles?
Again, in our current models, those are largely described, but not really derived from the geometry of spacetime itself. They're properties we observe and build into the model, rather than properties that emerge from the model's foundation.
That's sort of patched on, as you said.
Yeah, exactly. And then you have the really weird stuff, like quantum entanglement. Non-locality. It seems to defy our standard causal picture within Einstein's spacetime.
Spooky action at a distance, as Einstein called it.
It hints that maybe our understanding of space and separation isn't quite right at the deepest level. These aren't just minor glitches. They're persistent conceptual challenges.
They strongly suggest that maybe our whole foundational concept of spacetime might be the thing that's incomplete.
It's incredibly descriptive, our current physics. It tells us what happens with amazing accuracy, but it doesn't always tell us why it must happen that way. It lacks that generative power for some key features.
Which brings us right back to Lilien's alternative.
Yeah.
Finsler Coherence Phase. So, the core idea. Break it down for us. No spacetime grid.
Right. Forget the coordinates as primary.
Yeah.
Instead, the fundamental building blocks are coherence vectors. Think of them not as points, but as directional flows, flows of interaction, maybe information potential.
Okay, dynamic flows instead of static points. And dimensions.
Dimensions aren't assumed. They aren't the background stage. They emerge from the patterns and interactions of these coherence vectors. They're derived properties of what Lilien calls the omnilectic coherence tensor, this sort of foundational, multi-directional coherence field.
So 3D space isn't just there. It arises from this deeper coherent structure.
Exactly. And time, too. Time isn't a separate axis like XYZT. It's described as an emergent phase-like evolution direction.
Phase-like a wave's phase.
Sort of. Think of it as a property of how the coherence itself flows and changes, how it evolves. It's not something you move along independently. It's a characteristic of the coherence dynamics.
And particles, where do they fit in?
Particles aren't little billiard balls moving in this phase space. They are phase space, in a way. They are specific, stable patterns, stable configurations of the coherence field itself. Lilien calls them coherence eigenstates.
Eigenstates, like stable energy levels in quantum mechanics.
Analogous, yes.
Yeah.
But here, there's stable geometric patterns within the coherence field. So existence itself is redefined as being a stable coherence pattern.
Wow. Okay, that is a huge conceptual shift. And to describe this mathematically, he uses Finsler geometry. Why Finsler? What does that bring to the table that standard Riemannian geometry Einstein's math doesn't have?
This is absolutely key. Riemannian geometry is fantastic, but its metric, the thing that defines distances and curvature, only depends on position, where you are.
Okay.
Finsler geometry generalizes this. The Finsler metric depends on both position and direction.
Direction, like the direction you're moving or looking.
Exactly. Think of it like this. In standard geometry, space is isotropic, at a point the same properties in all directions, a perfect sphere. But Finsler geometry allows for anisotropy. Properties can change depending on the direction.
So space itself could have a grain or preferred directions, depending on how coherence is flowing.
Precisely. And this is crucial because reality, especially when you look at quantum phenomena, is directional. Think about spin, polarization, momentum flow. A purely position-dependent metric can't intrinsically encode that directional information.
It has to be added on later.
Right. But a Finsler metric can build it right into the geometry from the start. It's designed to model systems where directionality and flow are fundamental. It inherently captures the anisotropic, resonance-driven nature Lilien proposes for reality.
That makes sense. If reality is about coherence flows, the geometry needs to know about directions. So this name, phase space, it's not just catchy.
No, it's very deliberate. Phase plus space. It reflects several core concepts. First, as we said, temporality time is an emergent coherence phase.
Not a coordinate.
Not a coordinate. Second, it emphasizes the dynamic, flow-based ontology of dimensionality. Dimensions emerge from flow, not the other way around.
Third.
It mirrors the field resonance structure that he claims everything emerges from particles, forces, all of it. It's truly meant as a replacement for space-time.
Okay, so just like Einstein's space-time replaced Newton's absolute space and time by making them relative.
Lilien aims for phase space to replace space-time by making even more concepts, observer, field, coherence itself, emergent properties of the geometry. It integrates everything.
It's a geometry that inherently includes things like spin and directionality, rather than adding them as extra ingredients.
Exactly. A more fundamental and hopefully more complete geometric object.
So if phase space is the stage, the phase space tensor metric, this phi xy, is the heart of it all. This is where the maths get serious, but let's focus on what it does. You said traditional metrics are symmetric and position only.
That's right. Symmetric means the distance from A to B is the same as B to A. Position only means it doesn't care about direction. That structure inherently can't capture things like handedness or internal twists or flow dynamics directly.
But quantum reality has handedness, chirality, it has spin direction, it has flow.
Precisely. So you need a more sophisticated metric. Lilien defined his phi with 3 key parts. Let's break them down conceptually.
Okay, part 1.
Part 1 is the base metric. Let's call it GUMX. This is like the underlying background curvature of the coherence field. Think of it as the stage upon which the more complex dynamics play out. In a very simple, decohered limit, like empty space, far from anything interesting, this part would look like the flat Minkowski space of special relativity.
So it contains the familiar space-time geometry as a limiting case.
Yes, it's the foundation. But then comes the really Finslerian part. Part 2 is the coherence connection term. This depends explicitly on the direction vector of a wave.
The key part, okay.
This term describes how the coherence itself flows and changes directionally. It captures the dynamic currents, how they bend, how they interact based on their direction. This allows for things like non-reversible transport moving along a path might change the path itself and subtle phase shifts. That's pure Finsler.
Non-reversible. Wow. Okay. And the third part?
The third part is really crucial. The chirality torsion coherence term. Let's call it Ching, XY. The key thing here is that this term is fundamentally antisymmetric.
Antisymmetric meaning if you swap the indices E and E, it changes sign. Kuni.
Exactly. And that mathematical property, antisymmetry, is what allows it to intrinsically encode handedness, left versus right spin projections. It also encodes local parity violation, the universe not being perfectly mirror symmetric, and the internal twisting of coherence vectors, which is torsion.
So chirality and torsion aren't added features. They are baked into this antisymmetric part of the fundamental metric.
Precisely. In flat, simple spacetime, this key term would be 0. But Lilien argues it becomes dominant and crucial in highly resonant conditions near high spin states, or perhaps in the very early universe. It's the geometric source of these properties.
That's a huge claim. And what about time? How does that emerge from this film metric?
This is one of the most profound aspects. Time is not an input coordinate exterior, it's generated. Lilien shows that the proper time experienced along a path is found by integrating the coherence curvature along the direction of that path.
Integrating the curvature.
Yep.
Okay, unpack that.
Think of it like this. The phi metric defines the texture of phase space, including its curvature. When a field configuration, a particle moves through phase space, it interacts with this texture. If the particle has certain properties related to mass, it experiences a kind of drag or phase lag due to this interaction with the coherence curvature.
And that phase lag is time.
That cumulative phase lag, integrated along its path, is what we perceive as the passage of proper time for that particle. So massive particles inherently interact more strongly with the curvature, accumulate more phase lag, and thus experience time more slowly relative to less massive ones.
And massless particles, like photons.
For them, the path they follow is a null coherence path. Along that path, the relevant part of the metric phi is 0, no interaction causing phase lag. So they experience 0 proper time, timeless propagation. It elegantly recovers that known property of light.
That's a completely different way to think about time. Not a river we flow down, but an effect of our interaction with the geometric background.
Exactly. It's an emergent property of the coherence field's dynamics. And this metric structure also makes chirality and torsion intrinsic. Because the Singen term is antisymmetric, it naturally generates chiral resonances handedness. Because the coherence connection term can be non-commutative in its indices, it naturally generates torsion, an internal twist.
So these fundamental properties just fall out of the mathematics of the metric. They aren't assumptions.
They're consequences of the geometry he proposes. It's a potential game changer for particle physics, deriving these things instead of just describing them.
And Lilien shows how you can recover familiar physics by turning down these extra complexities.
Yes. If you set the chirality torsion term kin to 0, you lose handedness, parity violation disappears. If you set the direction-dependent coherence connection term to 0, you lose the Finsler aspect, and you're back to standard Riemannian geometry.
Like Einstein used.
Right. And if you simplify the base metric Gaussian down to the simplest possible form, the Kronecker delta, you get basic Euclidean geometry, flat, directionless space.
Which, in this theory, is the state of full decoherence.
Yeah.
Maximum simplicity, minimum structure.
Exactly. And the equations also naturally distinguish between paths where fungia is 0, light-like coherence, like photons, and paths where it's positive, time-like coherence, massive field evolution.
So the big aha moment here is that the simple Euclidean space we learn about in school, the one we intuitively grasp, it's not fundamental at all.
It's the end point. It's the 0 coherence limit of phase space. It's what's left when all the rich, dynamic, directional coherent structure has faded away.
It completely flips the script on what space is. It's not the foundation, it's the rubble.
Or perhaps the calm surface of a very deep and turbulent ocean. The structure is underneath.
A great analogy. Okay, let's move on to mass. This is another huge puzzle in physics. The standard model uses the Higgs mechanism, but as we said, it feels ad hoc. It doesn't explain the why.
Right. It postulates a scalar field, particles interact with it, gain mass. But the mass values themselves, the hierarchy, the existence of generations, they're parameters you have to measure and plug in. It's not derived from first principles. It's ontologically detached, as Lilien might say.
So how does fast space handle mass?
Yeah.
No Higgs field.
No separate Higgs field needed. In this framework, mass isn't added to particles. It emerges from their internal dynamics within fast-space geometry.
Emerges how?
The core principle is that mass is a measure of the internal coherence reduction of what Lilien calls a hyperspinor field, projected through this fast-space tensor metric view.
Hyperspinor field.
Yeah.
Okay, so a particle isn't a point, it's this more complex field structure with internal dynamics.
Exactly. Think of it as having internal degrees of freedom, internal structure. If this hyperspinor field is perfectly coherent, perfectly ordered, internally symmetrical, then it's massless.
Like a perfectly smooth symmetrical wave.
Kind of. But when its internal symmetries break, when that coherence gets reduced, twisted, becomes asymmetric, that's when mass appears. The degree of that coherence reduction is its mass.
So mass is like a measure of internal complexity or asymmetry.
Precisely. Lilien introduces a coherent scalar, x. If this scalar is 0, the field is massless. If it's non-zero, mass emerges dynamically due to this broken internal coherence. It's tied directly to the field's own structure and its interaction with the phase space geometry.
Okay, and this leads to a specific equation for mass.
Yes, the tensorial mass emergence equation. It's mathematically quite elegant because it directly links mass to the components of the phase space metric we just discussed. Conceptually, mass comes from three main sources.
First,
The first term involves the basic coherence metric, phi, and the direction u. This term accounts for the basic path structure and applies even to massless particles where it might contribute 0.
okay, the baseline.
Yeah.
The second term explicitly couples the chirality component of the metric, that antisymmetric term, to the particle's internal spin. So if a particle has spin and interacts with the chiral part of the geometry, it contributes to its mass. Handedness generates mass.
And the third.
The third term couples the torsion component of the geometry, let's call it tin, to something called the coherence current jek, which represents the internal twisting or flow dynamics of the hyperspinor. So internal twist also generates mass.
So putting it together, massless particles essentially only feel the first term. But if a particle has chirality, handedness, and air torsion, internal twist, these properties, interacting with the corresponding parts of the phase space geometry, create its mass.
Exactly. The more asymmetric its internal resonance, the more chiral or twisted its coherence flow is, the higher its mass will be. It's a derivation of mass directly from the geometric interactions. No separate Higgs field required.
That's profound.
Yeah.
And does this help with the Fermion generations, the electron muon tau problem?
Yes, this is another area where the theory claims significant explanatory power. In phase space, these different generations aren't just arbitrary copies. They are interpreted as quantized coherence eigenstates.
Quantized again, like energy levels.
Precisely the analogy. Lilien proposes a coherence eigenvalue equation. Chen equals nen. Here, Chen is a coherence operator derived from the phase space geometry. N is the wave function for the nth coherence eigenstate, like the electron state or the muon state. And m is the corresponding quantized mass.
So mass itself is the eigenvalue here, not energy.
In this context, yes. Mass becomes a discrete quantized property determined by which stable coherence state the particle is in.
And what determines these allowed states, these mass levels?
It's defined by the shape of what Lilien calls the coherence potential well, VCOX. This isn't a physical well, but a potential landscape created by the phase space geometry itself.
What contributes to this potential?
It has components related to the background coherence curvature, Rx, the chirality phase density, Chx, which selects for handedness, and the torsion modulation X, which introduces twist. The interplay of these geometric factors creates a complex potential landscape.
And the different Fermion generations are?
They are like resonant standing waves within this potential well. Just like a string fixed at both ends can only vibrate at specific frequencies, harmonics, a particle's hyperspinor field can only settle into specific stable resonance patterns within this coherence potential. Each stable pattern corresponds to a generation with a specific mass eigenvalue.
So the mass spectrum, electron mass, muon mass, tau mass, is determined by the shape of this geometric potential.
Exactly. It replaces the arbitrary Yukawa couplings of the Higgs mechanism with geometrically derived spectral states. The hierarchy of masses emerges from the structure of the coherence potential well.
That's incredibly elegant if it holds up. What about neutrinos? They're oscillations in tiny masses.
The standard model explains oscillations through mass mixing matrices, which is mathematically functional, but conceptually a bit complex.
Right. Flavor states aren't mass states.
In phase space, it's framed differently. Neutrinos are considered superpositions of these fundamental coherence eigenstates. They don't settle into just one mass eigenstate easily.
They're a mix.
A mix of coherence modes. And the oscillations we observe emerge naturally from the interference between these different coherence modes as the neutrino propagates through fast space. The geometry itself, particularly torsion and curvature gradients, modulates this interference pattern, causing the neutrino to shift between different observable states.
So oscillations are a geometric interference effect.
Yes. And flavor, electron neutrino, muon neutrino, tau neutrino, isn't seen as a fundamental property either. It's interpreted as the projection of the hyperspinor eigenstate through different observer coherence frames.
Meaning how we measure the neutrino influences what flavor we see.
Essentially, yes. The measurement interacts with the neutrino's superposition of coherent states within a specific geometric context, our detector, the surrounding space. And that interaction projects out a specific flavor outcome. Flavor becomes a contextual, observational result, not an intrinsic fixed label.
Mind-bending. Okay, let's broaden the scope. We have particles and mass emerging from geometry. What about the fundamental laws, the field equations? Physics currently has Einstein's equations for gravity and the standard model Lagrangian for everything else. Separate worlds.
A major point of fragmentation, yes. Lilien's unified coherence theory aims to unify them completely. All fields, all interactions, all dynamics are proposed to derive from a single variational principle applied to fast space.
One source for everything.
That's the goal. From this single foundation, he derives 6 core coherence field equations, CFEs. These are intended to replace and unify Einstein's equations, Dirac's equation, Maxwell's equations, Yang-Mills equations, all of them.
6 equations to rule them all. Let's walk through them conceptually. What's the first one?
The first is the coherence flow equation. Think of it as a generalized Dirac equation, but operating in phase space. It describes how these fundamental hyperspinor fields evolve. Crucially, the mass term, MEF, in this equation, is dynamic. It emerges from the coherence properties. It's not put in by hand.
Okay, field evolution with dynamic mass. Next.
Second, the coherence curvature equation. This is the analog to Einstein's field equations. It relates the geometry of phase space, GMS, which is related to phi, to the coherence energy momentum tensor, which describes the distribution and flow of coherence. This equation inherently includes gravity as coherence curvature, but also integrates the directional resonant aspects.
So gravity isn't separate. It's just one aspect of the overall coherence geometry responding to the coherence field.
Exactly. Third is the chirality resonance equation. This equation governs the dynamics of chirality fields, which are sourced by the spin structure of the hyperspinor fields. It describes how handedness, polarization, and parity violation arise and propagate.
Makes sense. Fourth,
the torsion resonance equation. This describes the dynamics of the torsion field, which is sourced by the internal twisting or coherence current of the hyperspinors. This is key for phenomena like the neutrino oscillations we discussed, linking internal twist to observable effects.
Fifth, getting complex.
Fifth is the coherence eigenmode equation. This is the quantization law we touched upon earlier, Ayer-in, Key, and Valonen. It establishes that the stable particle states are discrete eigenstates of the coherence operator C with specific quantized masses, N and M. This formally replaces the arbitrary mass parameters of the standard model with derived eigenvalues.
The rule that dictates the allowed particle types and masses. And sixth.
Finally, the coherence gauge field equation. This generalizes equations like Maxwell's for electromagnetism and Yang-Mills for the nuclear forces. It proposes that all fundamental interactions, electromagnetism, strong, weak, maybe even dark forces, are different curvature modes or aspects of the single underlying fast-space tensor metric phi xy. The source G is the coherence current of the hyperspinor field.
So one geometric field, Fin, manifesting as different forces depending on how its curvature is expressed or interacts.
That's the core idea, unification through geometry.
And all 6 of these equations, they come from one single source.
Yes, that's the claim. They are derived via the principle of least action from a single, fundamental, unified coherence action functional, SECT. This is the master blueprint.
Like the Einstein-Hilbert action gives GR, or the standard model Lagrangian gives particle physics, but this one supposedly does it all.
That's the ambition. SECTE is an integral over phase space, and its Lagrangian density is composed of several terms, each representing a fundamental aspect of coherence dynamics.
Can you briefly describe what each term represents?
Sure. There's L-flow, the coherence kinetic term, generalizing the Dirac-Lagrangian for field propagation. Then L-spin, the chirality resonance term, coupling the field spin to the chirality field M, generating handedness effects. Then L-torsion, coupling the field's internal twist to the torsion field O. There's L-curve, the coherence curvature term, involving the Ricci scalar R derived from the fast space metric. This replaces the Einstein-Hilbert term and generates gravity as coherence curvature.
Unifying gravity.
Then L-gauge, the gauge field curvature term involving Fume. This term unifies all the fundamental forces as different geometric modes of the fast space metric. And finally, L-self, a self-coherence interaction term, often involving terms like L-acre. This is the dynamic mass generator, replacing the Higgs mechanism's Yukawa couplings and creating the coherence potential well that leads to quantized mass levels.
Wow. So that one action functional contains terms for flow, spin, torsion, curvature gravity, gauge forces, and mass generation.
Yes, and the power comes from the variational principle. When you vary Saki with respect to the hyperspinor field, you derive the coherence flow equation. Vary it with respect to the phase-space metric fin, you get the coherence curvature equation, gravity. Vary it with respect to the chirality field min, you get the chirality resonance equation, and so on for torsion min, the eigenmode n, and the gauge fields n.
So each of the 6 fundamental equations naturally emerges from minimizing the single action functional.
That's the mathematical heart of the unification. Motion, force, mass, field structure, all unified outputs of one underlying coherence principle expressed through this action.
Incredible. Okay, let's shift gears slightly. What about conservation laws? Energy, momentum, charge. Noether's theorem ties these to symmetries in classical physics. How does phase space handle this?
Classical Noether's theorem is powerful, linking continuous symmetries to conserved quantities. But Lilien argues it has limitations, especially in a quantum dynamic geometry like phase space. It's based on global symmetries, struggles with local variations, and doesn't inherently quantize conserved quantities like charge. Why is electric charge discrete? Noether doesn't fully explain that.
So phase space offers a different take.
Yes, it introduces Noetherian Finsler numbers. These aren't just continuous conserved quantities, they are quantized units of conserved symmetry. Think of them as discrete packets of symmetry inherent in the phase-space geometry.
How are they generated?
It starts with the coherence current,
Really?
Kujuaba. This current represents the flow of inherent structure like spin, polarization, etc. through phase space. Crucially, it depends on both position x and coherence direction y. It's conserved locally, ashar 0.
Okay, a directional current.
From this current, the Noetherian Finsler number nin is defined as an integral of the time component of this current J over a coherence-preserving region. It represents a quantized amount of conserved symmetry associated with that region and flow pattern.
So not just charge, but a quantized packet of, say, spin symmetry or momentum symmetry.
Exactly. They are quanta of coherent symmetry embedded in the geometry. There'd be a Finsler number ne for momentum energy coherence, n for chirality helicity, ne for electrical or weak charge analogs, and even n for the mass level generation index itself.
And the quantization comes from.
It comes from the eigenstate structure inherent in phase space. Just like the coherence operator C had discrete mass eigenvalues, other symmetry operators associated with these currents also have discrete spectra of eigenvalues, the Noetherian Finsler numbers, nen. This explains why charge is quantized and stable. It corresponds to a specific allowed eigenvalue of a coherent symmetry operator.
So quantization is built into the symmetry structure itself.
Yes, and this leads to the unifying algebraic structure, the coherent symmetry algebra, C or SCO. This algebra is designed to encompass all physical operations, coherence, flow, conservation laws, quantization of mass, spin, flavor, interactions. It's proposed as a replacement for the Poincaré algebra of spacetime and the SU3XSU2RU1 Lie algebras of the Standard Model.
A single algebra for everything. What are its fundamental building blocks? Its generators.
The generators are operators that act on the hypersteiner states. There's emes for coherence translation, related to momentum. Emin is the chirality generator, spin-handedness. Emin is the torsion generator, internal twist. Rhomin relates to curvature resonance, gravity geometry, and Emin is the eigenmode projector we met earlier, selecting mass generation.
And how these operators relate to each other mathematically tells us how different aspects of reality are linked.
Precisely. The commutation relations are key. For instance, Emin conceptually means that asymmetry in coherence flow generates chirality, spin.
Flow creates handedness.
And any, ageno means chirality distortions induce torsion, twist. Spin influences internal twisting.
Okay.
And maybe most profoundly, aili, iomio, implies that internal torsion generates coherence curvature. Gravity emerges from the internal twisting and flow of coherence.
Gravity as a resonance curvature from torsion.
That's wild.
The eigenmode projectors also have relations. Aom, showing they represent distinct, stable, orthogonal states, ensuring particle types are well-defined and don't just bleed into each other.
And things like mass and charge.
They correspond to Casimir operators of this algebra operators that commute with all generators and thus have definite quantized values for each stable particle state representation.
So particles are just specific representations of this coherence algebra, defined by their symmetry eigenvalues.
Exactly. An electron is a state with a specific mass eigenvalue, a defined chirality, eigenmodes Iz, minimal torsion eigenmure, and its mass μ comes from the Casimir operator.
And a photon. It's the massless state, hollows a null coherence path, Ca, has pure helicity, Ca, and is torsion-free, Ca0.
And neutrinos.
They have minimal mass, strong chirality, Ca, exist as a superposition of eigenmodes, and their oscillations are driven by non-zero torsion interactions, Ca, CO0. Particle properties become direct readouts of their algebraic structure within phase space.
Okay, that covers fundamental particles and laws. How does this framework handle composite particles like protons and neutrons? Are they just quarks stuck together?
Not quite in the simple stuck-together sense. Lilien proposes they aren't bound states of solid point particles, but rather stable resonance configurations of multiple coherence eigenmodes entangled across shared coherence fields.
Entangled eigenmodes, so more like overlapping phase-locked wave patterns.
Exactly. Think of phenomena like quark confinement, not as some extra force, but as a consequence of the coherence algebra. Certain combinations of coherence eigenstates, quarks, can only form stable phase-locked configurations when combined in specific ways, like three quarks and proton, sharing curvature, torsion, and chirality modes to create a stable, extended coherence domain. Isolation would be an unstable configuration.
Is there a rule for how they combine?
Yes, a coherence tensor fusion rule, ACOM. Stability requires the composite state ACOM to still be an eigenstate of the relevant coherence operators.
So a proton.
Conceptually, three resonance states lock together, perhaps canceling out net torsion and achieving a stable chirality phase. Its mass and spin emerge from this fusion. A neutron is similar, but with a subtle internal phase shift, resulting in slightly higher residual torsion, which Lilien links to its instability and decay channel.
And particles like pions, the mediators.
Described as a coherence-anticoherence pair, oscillating rapidly. Their very low mass is attributed to phase compression and cancellation of curvature effects within the pair. They act as transient resonance bridges.
Fascinating. What about the elephant in the cosmic room, dark matter? Still some exotic particle we haven't found.
Lilien suggests maybe not. Dark matter could be composed of stable coherence configurations with non-intersecting resonance manifolds relative to the visible sector.
Non-intersecting resonance manifold, meaning...
Think of it like their vibrational modes or coherence patterns exist in a way that's orthogonal or non-resonant with the modes of our ordinary matter and light. Their coherence curvature doesn't align with ours.
So they don't interact electromagnetically because their coherence channel is different.
Precisely. Dark equals 0. They're invisible because they don't talk to photons in the usual way. Examples could include a coherence neutrino, a stable, torsion-tuned eigenmode weakly coupled to ours, potentially explaining galactic mass deficits. Or even coherence condensates, vast, macroscopic domains of aligned coherence flow, acting as the invisible scaffolding for galaxy formation.
So dark matter isn't necessarily new matter, but perhaps ordinary coherence behaving differently, existing in a non-resonant state relative to us.
That's the idea, interacting primarily through its gravitational effects, coherence curvature, and potentially very subtle coherence field interactions.
This leads us to another huge leap, the origin of dimensions themselves. We usually just assume 3 space plus 1 time. You said phase space argues they emerge.
Yes, dimensions are emphatically not fundamental inputs or containers in this theory. They emerge as resonance structures during what Lilien calls the coherence cascade.
Coherence cascade.
Imagine starting from a state of perfect, undivided unity hypercoherence, where a coherence order parameter C is 1. As this parameter decreases, reality undergoes a stepwise reduction in symmetry. Each step involves a phase fixation, a loss of symmetry, and the emergence of a new, stable coherence eigenstructure, which we perceive as dimensionality.
Like water freezing into ice crystals. The structure emerges as energy is lost.
A good analogy. It's a hyperfractal cascade of symmetry reduction and dimension crystallization. Lilien outlines a possible sequence. Near C1, you have an infinite dimensional hyperfield. As C drops maybe around 0.85, a 1D oscillatory phase emerges, like a proto-EM field. Around 0.60, perhaps an SU2 chiral layer forms a 2D spinor plane where handedness appears.
Okay.
Around C0.333, maybe an SU3 structure emerges associated with 3D space curvature and color charge phenomena. Then around C0.125, we get the dimensional lock-in, our familiar 3+1 observable spacetime formed by coherence collapse. Below a certain threshold, C0.085, structure dissolves into decoherence and chaos.
So our 3+1 dimensions are just one stable phase in this cascade, a particular level of coherence.
Exactly, a specific resonance structure that became dominant.
And time. Does it emerge similarly?
Yes, time also has layers. At C1, it's a temporal, an eternal now. Around C0.5, maybe time is cyclic based on resonant recurrence. Only when spacetime locks in around C0.125 does linear directional time emerge as we experience it, a modulated gradient of coherence resonance, not a fundamental axis.
This completely changes cosmology. No Big Bang singularity.
Lilien proposes a big emergence instead, not an explosion from a point, but a continuous unfolding, a progressive cascade of coherence reductions starting from hypercoherence. Symmetry breaks, dimensions crystallize, fields precipitate, particles form, time linearizes, no infinite density needed.
How does the universe evolve in this picture?
Governed by a cosmological coherence curve, dc/dt equals of fsc. Coherence acts as a structuring gradient. The universe self-organizes by losing coherence, moving towards more structured but less unified states. It's evolution through structured loss, not just random expansion.
And large-scale structures like galaxies.
They form not just by gravity pulling stuff together, but from coherence resonance shells. A central coherence attractor, like a black hole, forms, and the surrounding structure's spiral arms, halos emerged as phase-stabilized flow domains and harmonics within the galactic coherence field.
Spiral arms is coherence harmonics? That could explain their persistence. And galactic halos.
Interpreted as phase leakage, and coherence condensates regions where the dark matter coherence field is dominant. This intrinsically links visible structure to the proposed dark matter scaffolding and could potentially explain flat rotation curves without exotic matter.
What about the cosmic microwave background, CMB, the afterglow of the Big Bang?
Reinterpreted as the coherence field's thermalized resonance signature from the era of dimensional lock-in. Its incredible smoothness reflects resonant averaging, the tiny temperature fluctuations are residual coherence interference patterns, and its polarization patterns could be traces of residual torsion fields from the cascade.
It reframes all our cosmological observations through the lens of coherence.
It attempts to provide a unified narrative from the quantum to the cosmic based on this single principle.
Okay, the implications here are staggering. If this framework has any truth to it, what does it mean for technology? It sounds like a completely different paradigm.
It really is. The focus shifts from manipulating matter and energy directly, using brute force, to modulating the underlying coherence fields and symmetries.
Like what? Give us some examples from Lilien's work.
Well, zero-point coherence extraction. The idea is that the vacuum isn't empty, but a sea of high coherence. If you could locally modulate its symmetry, create specific resonance patterns, you might induce it to release phase-locked energy. Energy release would come from reducing local coherence. Think toroidal coherence chambers, scalar lattice resonators tapping the vacuum structure.
Accessing vacuum energy by detuning its coherence.
That's the concept. Or consider coherence-based fusion. Instead of just smashing nuclei together with immense heat, you'd use precisely tuned coherence fields to phase-align the nuclei.
Phase-align them?
Yes, align their internal coherence structures. This could effectively dissolve the Coulomb barrier, their electrostatic repulsion, by making them resonant with each other. Fusion would occur under coherence pressure, PC echo dV, rather than thermal pressure. Fusion reactors become resonant field architectures. Low-energy nuclear reactions might become feasible.
That would change everything. What else?
Coheraputers. Computing not with bits, but by manipulating coherence phase fields across fast space. Using torsion gates, eigenstate routers, recursive condensers. Operating on fractal logic, where outcomes are tied to the observer state, a completely different way to process information, potentially vastly more powerful for certain problems.
Motion propulsion, anything like warp drive.
Maybe closer to scalar field propulsion or anti-inertial systems. The theory posits inertia itself is a form of coherence curvature memory, resistance to changes in coherence flow. If you could actively reconfigure the local coherence curvature tensor, or local-lun, around a craft using scalar phase emitters.
You could nullify inertia.
Potentially. Or create directional resonance propulsion. It opens doors to inertial shielding, perhaps even stabilizing exotic geometries like wormholes using coherence threadlock fields. It sounds like science fiction, but it follows logically from the proposed physics.
Are there biological implications too?
Huge ones. Lilien views living systems as complex, nested coherence engines. DNA might act as a scalar wave antenna, cell membranes as resonance boundaries. This suggests possibilities like scalar healing, using coherence fields to entrain biological systems back towards healthy resonance patterns.
Tuning the body's coherence.
Or targeted cancer treatment by using torsion fields to destabilize the chaotic coherence of tumor cells. Even consciousness modulation via phase-locking specific neural coherence patterns. Diagnostics could involve mapping the body's coherence field alignment.
This framework seems to inevitably draw consciousness into the picture.
Yeah.
How does it handle the observer?
Fundamentally differently. The observer isn't passive. Lilien describes the observer as an active meta-operator. Observation is an interactive coherence modulation. The act of observing actively reduces coherence and modulates the symmetry of the observed system. OHC collapsed.
So observing collapses the wave function by reducing coherence.
Yes, and the strength of the observation corresponds to the amount of coherence reduction. A strong measurement fully localizes a system, maximally reducing its coherence potential. A weak measurement might only slightly alter the coherence gradients.
What about qualia, the subjective feeling of experience, the redness of red?
This is highly speculative, of course, but the theory proposes a qualia field. Qualia emerge as internal holographic resonances formed when the observer collapses a coherence field into experiential structure.
So my feeling of red is a specific resonant pattern created in my consciousness when I observe red light collapse in the coherence field.
That's the conceptual picture. Qualia are resonant holographic events, dynamically structured by the observer's interaction with the coherence field. Each moment of experience, the now, is a collapsed slice of universal coherence flow, stabilized by the observer's own coherence structure.
It embeds consciousness right into the physical process.
It attempts to. And this leads to redefining intelligence, not just computation, but the ability to recursively modulate, stabilize, and amplify coherent structures. Recursive intelligence involves manipulating coherence dynamics based on feedback.
Recursive.
Meaning observing your own process of observation and coherence collapse and adjusting it. Recursive observer fields give rise to metacognition, intentionality.
And this leads to
Intelligence, not traditional AI, but a symbiotic coherence intelligence system. Imagine human recursive observers coupled with synthetic architectures designed to modulate coherence fields directly. Glyphic compilers, coherence engines, phase feedback interfaces, a fusion of mind and coherence technology.
application.
Potentially transformative applications in medicine, learning, problem solving, perhaps even art and ethics, by enhancing our ability to consciously interact with these deeper coherence structures. It points towards a future evolution that's not just genetic or digital, but based on developing refined coherence intelligence.
This is incredibly far-reaching. It culminates in a new Meta-ontology, a theory of being itself.
Yes. The fundamental statement is, being is coherence. What exists is stable coherence. What is knowable is resonant coherence. What is self-aware is recursive coherence. Ontology becomes dynamical coherence topology.
And mathematics.
Becomes the formal language of coherence resonance. Equations are compressed phase structures. Fundamental constants, C, are ontological attractors. Stable points in the landscape of coherence emergence.
Is there a final, ultimate equation in this theory?
Lilien proposes a conceptual, universal coherence tensor field equation. Unum plus rho plus O. This aims to unite everything symmetry, asymmetry resonance, and the observer function into one structure that generates gauge fields, matter, and consciousness through observer-driven selection.
And the ultimate fate of the universe.
Speculatively, an omega limit. The current coherence decay, expansion, increasing entropy might eventually reverse. High entropy could trigger a coherence resonance accumulation, leading to a spontaneous recohering of everything back into meta-unity. A cosmic inhale after the long exhale, perhaps recursive universe, pulsing between coherence and decoherence.
Wow, we have covered an immense amount of ground. From the problems with space-time, through fast-spaced geometry, emergent mass, unified forces, quantized conservation laws, emergent dimensions, dark matter, cosmology, wild future tech, consciousness, and meta-ontology, all tied back to this idea of coherence.
It's a vast, ambitious, and deeply integrated framework. It attempts to weave together threads from almost every area of physics and philosophy into a single tapestry based on coherence dynamics.
It's definitely not just tweaking the edges. It's a fundamental reconstruction, proposing that phenomena we see as separate gravity, quantum effects, mass, time, even consciousness, are all just different facets of this underlying directional resonant geometry of phase space.
The claim is that it brings a new level of unity, elegance, and ontological grounding to our understanding of reality, deriving what current theories often have to postulate.
Which leads us, and you listening, with a truly provocative thought. If reality is fundamentally this dynamic coherence field, and if our own consciousness isn't just a passive observer but an active coherence modulator, what does that imply?
What possibilities does that open up for how we interact with the universe, how we understand ourselves, and maybe even how we can consciously participate in shaping reality?
It's a profound challenge to our most basic assumptions about existence and our place within it, something deep to ponder.
Indeed. It suggests a universe far more interconnected and participatory than we might have imagined.
Thank you for guiding us through that absolutely mind-bending deep dive. And thank you all for joining us. Until next time, keep exploring, keep questioning, and keep diving deep.